epsilon steel in tension. That's fine. After strain distribution, we have something called stress distribution. Your stress block looks like this. A little bit behind your neutral axis with distance A. Your value here 0.85 F prime C. Remember, in the steel reinforcement in compression, we have a force called C steel. C means compression, S means steel. In concrete, we have another force C concrete. In steel reinforcement and tension, we have a force T. For acrobium, summation f of x equals 0, CC plus CS equal T. CC equal 0.85 F prime C AB plus CS. What is the value of compressive force in compression steel? Area steel prime F yield. Why F yield? Because I assumed your steel reinforcement yields equal T area steel time F yield. Go ahead and put your value. 0.85 F prime C3 A, I don't know, B 14 plus area steel 1.2 F yield 60 equal area steel 5.06 times F yield 60. The only unknown is your distance A. What is the value of A? Very simple. Very simple. This is the reason why we're starting with this option. Assume yielding in compression steel reinforcement. 5.06 times 60 minus 1.2 times 60 divided by 0.85 times 3 times 14. Your value 6.5. I think you can get your distance C. What is the value of C divided by 0.85? 7.6. Before finishing your problem, we need to check this assumption is correct or not correct. So, can you tell me what is this value is? Epsilon steel prime. Make triangle similarity between this triangle and the smaller one. So 0.003 divide epsilon steel prime equal the total distance C divided by this little distance C minus D bar. So C 7.6 divided by 7.6 minus D bar 2.5. The only unknown in this equation equal epsilon steel prime. Your value 0.002031. Epsilon yield equal F yield divide E steel. F yield 60, 29,000. What is the value? 60 divide 29,000. 0.00206. What do you think? Epsilon steel smaller than epsilon yield. That's right. This value is smaller than this value. So your assumption not correct. Do more calculation. So compression steel does not yield. So your equilibrium equation must change a little bit. A, B plus area steel prime F steel prime, not F yield, equal area steel F yield. This is the only change. So I will remove this value and put beta 1 C. I will remove this value and I will put something. What is your something? F steel prime equal epsilon steel prime time E. So E outside. What is the value of epsilon steel prime? You can get it from here. Neglect this one. You can get it from here, epsilon steel prime in one side. So everything on the other side will be C minus T bar divided C time 0.003. So your equilibrium equation will be 0.85 time FC prime 3. Beta 1, 0.85. C, I don't know. B, 14. Plus area steel prime 1.2. 1.2. That's right? Yes. Time F steel, all of this term. E, 29,000. C, I don't know. D bar, 2.5. Divide C, I don't know. 0.003. Equal area steel, 5.06 time F yield. The only unknown in this equation, what? C. It will be equation from second order. So we can simplify it. 0.85 times 3 times 0.85 times 14. Your value 30.35 C plus this value 1.2 times 29,000 times 0.003 equal 104.4 minus 1.2. Anyway, 1.2 times 29,000 times 2.5 times 0.003. Your value 261 divide C equal 5.06 times 60 3.0306. Any questions so far? Multiply this equation by C. So we have 30.35 C squared plus 104.4 C minus 261 equal 303.6 C. More simplification. 30.35 C squared minus 303.6 minus 104.4 199.2 C minus 261 equals 0. What is the value C? Plus or minus? No. Minus B plus or minus square root B squared minus 4 AC divided 2A. Solution for this equation. So minus B squared 199.2 squared minus 4 times A 30 plus 30 times C, which is negative 261. All of them under square root minus B divided by 2A. Your C equals 7.7 H. We have another value, will be rejected, will be negative. We have something 7.7 inch. So your distance A, which is equal beta 1C, C 7.7, beta 0.85. So your A value equal 6.53 inch. You will find this value very close to this value. Because actually this one, this term, very, very, very close to this term. So if you stop here, that's fine. Go ahead. First term, we have area steel 1 and your concrete, first part. Second part, we have area steel prime with area steel 2. Area steel 2 equal 1.2 because area steel prime 1.2. So can you tell me what is the area steel 1 will be? 5.06 minus 1.2, that's fine. No, 3.86. Between tension force here and the compression force here, we have Mn1 equal 3.86 area steel time F yield time your depth minus A divided 2. For the second one, we have tension here and have compression here, so Mn2 equal area steel time F steel time this is distance D minus D bar. How can I get F steel? Go back to this equation and get your area steel. C 7.7 minus D bar divide C time 0.003 time E Young's modulus. Your value of steel 58.75. As you see, what do you think here? For this steel reinforcement, your F yield equals 60. After your accurate calculation, your stress in compression steel equal 58, a little bit. 58 at this point. Okay? So you can find Mn1, you can find Mn2, Mn total equal Mn1 plus Mn2. Your design moment will be phi time Mn. So you are super lucky if you have double reinforcement and you assumed first assumption that your compression steel yields, and after you check, your steel did not yield. So you need to repeat your calculation. The only change will happen, your steel, your stress in compression steel, not F yield, it will be F steel. This F steel can be found from this relationship. This term, your strain, equal this value from triangle similarity. Once you get distance C from this second order equation, you can get A and then go ahead and do your calculation. Any question? Go ahead.
Well, that doesn't mean that we'd have to redesign what we got going on.
No, no.
We're just making sure
that you assumed your steel reinforcement yields. Your assumption isn't correct. So we did another calculation to get the actual value of Mn. Nothing wrong. But you have more steel reinforcement in compression because the optimum design to get the optimum strength. Okay, that means you have much reinforcement. That means your stress is very, very, very low. That means your design not economy. Remember all the time I told you nothing wrong in your design if there's something serious. But nothing wrong, but there is design which is economic and design not economic. Yep.
How did you get C 7.6? I think
7.6?
Yeah.
Once you get A from this equation, your A distance equal beta 1 times C.
Okay, yeah, okay.
So A 6.5, beta 0.85, you can figure out what is the value of C.
Okay.
Okay. Any question?
Can you explain how you drew your MN1 and MN2, the drawings?
MN1,
Yeah, the drawings.
this one?
Yeah.
Okay, one more time. Your double reinforced section can be divided between two parts. The first part of your area steel, which called area steel 1, and your concrete cross section. The second part, the remaining steel reinforcement, which called area steel 2, and your area steel in compression. This term must equal this one. I know this one, area steel prime 1.2, that's fine. So this one, 1.2. The remaining steel here equal the total area, which is 5.06 minus 1.2. Put them here together.
Please draw the second one first.
This part plus this part equal your total cross section. That's fine. So we have area steel here 5.06. We have area steel prime here 1.2. I want to start from this part. Your area steel prime is the same, 1.2. This area steel must equal this one, 1.2. So what is the remaining? We have 5.06 total. We took 1.2. The remaining here will be 3.86. If you add this value plus this value, you can get this one. If you add nothing here plus 1.2, you can get this one. Okay?
Thank you.
Yeah. Any question? That's enough for today. Prepare yourself to steel exam.